Okay, folks, for today's lesson, our goal is that you can identify an acid, base, or neutral compound by the pH value. And then I want you to be able to determine how much more acidic one solution is than another by comparing the pH values of the solutions. So you're going to take some notes on pH. You're going to practice identifying acids, bases, and neutral compounds by their pH values. And then you're going to practice comparing the acidity of different solutions. Okay, so recall that the formulas of acids always start with hydrogen, and the formulas of bases always end with hydroxide. And so when acids react with water, they will produce hydronium ions. So here we've got an acid, HA, and that's reacting with water. And so the H is actually going to move over to the water. So you're going to be left with A minus. So that's just whatever nonmetal was paired with the hydrogen. We're just going to have the negative ion that was paired with hydrogen. And then hydronium, this is hydronium right here, H3O+. So we've got acid reacting with water, and then one of the products is hydronium. When bases are dissolved in water, they will break apart to form hydroxide ions. So here we've got a base, right, just a metal paired with hydroxide, and that's going to split apart to form a metal ion. That's this B plus right here, and OH minus, which is hydroxide. So we've got our base, and then it'll break apart to form hydroxide. So this is hydronium, H3O+. This is hydroxide, OH minus. You might want to circle those two. Those are going to be important ions as we work through this lesson. So pH is a measure of how much hydronium and hydroxide is in a solution. Solutions with more hydronium and less hydroxide are acidic and have pH values between 1 and 7. Solutions with less hydronium and more hydroxide are basic and have pH values between 7 and 14. And then solutions with about the same amount of hydronium and hydroxide are neutral and have pH values that are close to 7. Right, so 7 is kind of the magic number for pH. That's sort of like the middle of the pH scale. Okay, so let's go through some examples of determining whether a different product is an acid, a base, or neutral from the pH value. So Coca-Cola has a pH of 2.3. 2.3 is in between 1 and 7. That makes it an acid. Dish soap has a pH of 7.2. That's close to 7. So we're going to say dish soap is neutral. Bleach has a pH of 13, right? That's in between 7 and 14. So we were going to say that bleach is a base. Okay, so then you go through the rest of these, try to determine whether they're acids, bases, or neutral. All right, pH is measured on a logarithmic scale. If you decrease the pH of a solution by 1 unit, the solution will have 10 times more hydronium ions and 10 times less hydroxide ions. In other words, the solution will be 10 times more acidic or 10 times less basic. You can determine how many times more acidic one solution is than another using the following expression. And so if we just take 10 and then we take the solution with the higher pH and subtract the solution with the lower pH, that's how many times more acidic the solution with the lower pH than the solution is with the higher pH. So let's try and use that formula to do a few example problems. So here we're going to compare Coca-Cola and dish soap. So here's Coca-Cola. Coca-Cola has a pH of 2.3. Dish soap has a pH of 7.2. So we know that the Coca-Cola is more acidic because the pH is lower. So look at your numbers, whichever one is lower, that'll be the more acidic thing. So in this case, Coca-Cola is more acidic than dish soap. Now we're going to calculate how many times more acidic. So remember, Coca-Cola had a pH of 2.3, dish soap had a pH of 7.2. So we're going to take the higher pH minus the lower pH, and we're going to take 10 to that power. So we're going to do 7.2 minus 2.3, right, because those were the numbers here, 7.2 for dish soap, 2.3 for Coca-Cola. 7.2 minus 2.3 is 4.9. And then we're going to take 10 to the 4.9 power on our calculator. So I'm going to show you how to do that in Google here. Do 10 to the 4.9 power. And we should get 79,433 if we round that up. So I'm going to write that in. 79,433. There's never any units for pH, so don't worry about units. Coca-Cola is 79,433 times more acidic than dish soap. Okay, let's do another example. Jalapenos and orange juice. Jalapenos have a pH of 4.8. Orange juice has a pH of 3.7. Again, whichever one of these is lower is the more acidic. So orange juice is more acidic than jalapenos. Again, we're going to use our formula. So we're going to type in 4.8 minus 3.7. So 10 to the 4.8 minus 3.7. 4.8 minus 3.7 is 1.1. 10 to the 1.1 power. Let's calculate that. 10 to the 1.1 is 12.6 roughly. So then we can write that in, 12.6. Okay, so orange juice is 12.6 times more acidic than jalapenos. Last up, we're going to do ammonia versus milk. So ammonia has a pH of 11. Milk has a pH of 6.7. That means that milk is more acidic because it has the lower pH. So milk is more acidic than ammonia. And so then we're going to take our higher number minus our lower number. So 11 minus 6.7. We're going to do 10 to the 11 minus 6.7, or 10 to the 4.3. Let's type that in here. 10 to the 4.3. That gets us to 19,953 if we round up, because that's a 6. So 19,953. Whoops. Okay, so then what does that mean? That means that milk is 19,953 times more acidic than ammonia. Okay, so then there's a few more practice problems here where you're going to compare the acidity of some different solutions, determine which solution is more acidic and how much more acidic, and then we'll go over this in class tomorrow.